whenever you're ready.
This is the Fire Ecology Group. My name is Chris, and this is Ashwin, Marcus, and Emily. Our research took place in Silver Falls State Park. There is an area in the southeast corner of the park that was burned during the Beachy Creek Fire of 2020. We went to 4 different locations: Cat 2.7, Unit 1, 2, and 3. Each site had a different forest restoration strategy after the fire. Cat 2.7 was left alone, Unit 1 was thinned, Unit 2 was logged, cleared, and replanted, and Unit 3 was partially logged, cleared, replanted, and partially thinned. Wildfires are increasing. In fact, there has been a 4% increase in the amount of acres burned in 49 U.S. states over the last 10 years. Carbon dioxide from fires contributes to climate change and harms wildlife and their habitats. The smoke degrades the air quality and also leads to health problems for humans. When forests are destroyed, soil erosion increases, which leads to pollution in waterways in the area. In addition, as climate change intensifies, there are more and more wildfires burning across the world. We are specifically studying the Beachy Creek Fire from September of 2020. Local communities were heavily affected and needed a lot of help to recover. First responders protected lives and people's homes. Many acres of forest burned and at least 5 lives were lost. Environmental organizations advocate for better forest management, including in advance of and after fires. As wildfires become more and more common, especially in the West, communities are concerned not only about how to avoid and prevent large fires, but also how to recover from them. Our research question is, what is the most effective strategy for restoring a forest ecosystem after a forest fire? Based on our background research and past JGIM studies, we hypothesized that the strategy used at Cat 2.7 of leaving the forest alone would produce the most effective recovery.
The Beachy Creek fires were a tragic moment in Oregon. Over 900,000 acres were burned. The fire began on August 20th, 2020, ignited by a lightning strike. The fire spread to communities like Mill City, Detroit, and many more. Approximately 80,000 people were forced to evacuate. Sadly, 5 people were lost in the fires. Miraculously, a windstorm hit on September 7th, 2020, and the fire maneuvered just enough to help firefighters extinguish the fire. As we know, forest fires are not an uncommon occurrence, but 2024 has had a devastating increase. Throughout the years, forest fires have become a more frequent natural disaster. One contributor to the rise of severe forest fires is climate change. Drought also increases the likelihood that fires will burn out of control. In addition, 90% of wildfires are through cigarette butts, unattended fires, or machinery malfunctions. Soon after the fire had ended, an environmentalist team named Burn Area Emergency Response dedicated themselves to helping restore parts of Silver Falls State Park by clearing, logging, and replanting burned spots. While the recovery process was in motion, there was a small issue. Typically, logging is illegal in state parks, but due to the fire, there was so much damage that the state allowed it. They also decided to log some of the park to raise money to help recover the forest, in part because it was such a small remote area where few people hiked. The history of JGIM's fire studies has had many generations of students starting in 2005. The past fire ecology groups have researched a multitude of spots, starting with the 2003 B&B Complex Fire, then the Dollar Lake Fire, the Eagle Creek Fire, Millie Fire, Whitewater Fire, and now the Beachy Creek Fire that took place in 2020. Our studies revolved around 4 units, named Cat 2.7, Units 1, 2, and 3. Again, each site had a different forest restoration strategy after the fire. Cat 2.7 was left alone, Unit 1 was thinned, Unit 2 was logged, cleared, and replanted, and Unit 3 was partially logged, cleared, and replanted, and partially thinned.
Materials used by the student researchers out in the field included a Quadrat 100-foot tape measure, clipboard, paper, pencil, mini paint roller, deionized water, and gloves. Materials we used in the classroom included computers, data sheets from the field, reference books, a vacuum pump, and small bottles. When taking data in the field, we used a very specific method. We drove to Silver Falls State Park to collect data on the recent burnings in the area. We walked down the Catamount Trail at mile 2.7 to find our location marker and old tree stump. This is the same spot JDM students have taken data since 2021. Once we had entered the area, we laid down a 100-foot tape measure perpendicular to the trail to be our transect. Every 25 feet, we placed a 1-meter quadrat that we split into quarters, and the student counted the number of lichen, plants, and fungus in their assigned quarter. These were added together and written down on the data sheet. Counting moss is a little more difficult. We decided to count moss by percentage of coverage within the 1 meter square. A closed fist is approximately 10 centimeters squared, so we counted that as 1% of the entire quadrat. We added the number of fistfuls together and used that as our percentage of coverage. We repeated the same process at each 25-foot interval on the transect until we were done with the first 100-foot tape measure. Once we reached the end of the tape measure, we counted all the trees, including saplings, that were within 6 feet of the transect on both sides. As we walked back along it to the trail, we identified them and recorded them on our data sheet. Once we finished the transect, we moved on to the environmental DNA portion of data collection. We got our mini paint rollers out and pulled off the plastic covering, keeping them dry and clean. Then we took them to a mature tree, rolled them up and down all the way around as high and as low as we could go. We were sure to wear gloves while doing this to avoid getting human DNA on the paint roller, which could contaminate the sample. We put the mini paint roller in a tub of deionized water, shook it around, and then took it out and closed the container. Once the water was contained, we took it back to the school and used a vacuum pump to get all the eDNA onto a little filter. Then Mr. Whittle took them to Oregon State University to be analyzed. OSU has a machine that takes our eDNA and compares it to all the DNA strands that it has in the machine's genome database to see which is the most comparable to what we got. We found that Cat 2.7 had the most fungi, lichen, and moss life out of the 4 research locations. We believe this is because it had the most shade and tall standing trees. This fits perfectly with our hypothesis about Cat 2.7 having the most regrowth of the 4 locations. Looking at Cat 2.7 over the 4 years of our study, the plants per square meter increased the first 3 years after the fire, but then decreased this year.
We counted western hemlock and Douglas fir saplings along the 100-foot belt transect at each of our 4 sites. We found significantly more western hemlock in Cat 2.7, while Units 1 and 2 had more Douglas fir. Unit 3 had a large number of both species. Our eDNA results showed only evidence of human presence. After analyzing our data, we can answer a research question. What is the best strategy to recover forest ecosystem after a forest fire? It was clear that Cat 2.7 had much more plant life, moss, fungi, and lichen than the other locations we studied, indicating that it's doing better on its own than the areas where they did more active work like logging or clearing. This suggests that in the early stages of recovery, allowing nature to take its course could be more effective than forcing recovery through interventions like clearing or replanting. This may change over time, but for now, Cat 2.7 has the best results. Moss was another feature that stood out at Cat 2.7, with the highest coverage by far among all sites. In Units 1, 2, and 3, heavier equipment was used to thin and clear the sites. This probably damaged any surviving moss. Moss thrives in shaded, wet environments, and the thick canopy at Cat 2.7 keeps the area cool and moist, making it perfect for moss to establish. The abundance of moss suggests that the area has excellent water retention, which would aid in recovery. Moss plays a critical role in preventing soil erosion and maintaining soil health, further supporting the forest's regrowth. Why did the number of plants drop this year? We we noticed that the plants in Catchment 7 were more mature than in past years. We believe the larger plants have outcompeted the smaller ones, leaving fewer but more plant coverage. When we counted saplings in Catchment 7, we saw that western hemlocks were growing much more than Douglas fir. We initially predicted that Douglas firs would dominate, but western hemlock thrived in the shaded, moist environment of Catchment 7, giving them a distinct advantage. The other units showed more Douglas fir saplings. Unit 3 surprised us by having a lot of both species. The sum of trees and saplings at Unit 3 is similar to the sum of the trees and saplings at Catchment 7. This could be due to replanting or some unconsidered variable. Douglas firs, on the other hand, did not do as well as we expected at Catchment 7. They grow best in full sun or partial shade. In the open areas of Units 2 and 3 where they had logged and cleared the sites, this was ideal for replanting Douglas firs. Even though we tried our best, mistakes and limitations were bound to happen. In Unit 2, it was so rainy and cold that we decided to leave early since it was hard to take data when our hands were shaking. For Unit 3, our group didn't have time to visit, so Mr. Weddle took our data for us. After reflecting, we realized we could have made a lot of human errors, such as when counting the saplings. We didn't have a precise way to make sure all the saplings were accounted for, so it's possible they were recounted multiple times. Another time we may have made an error is getting our DNA on the eDNA samples. Because of the weather, we were limited in the number of eDNA samples we could collect. The only eDNA that was detected was human. If we were to fix these mistakes, our group would bring hair nets to make sure no hair gets on the samples and only have one person handling all of the eDNA. For future researchers, our recommendation is to pause the study of forest regrowth for 2 years. This will allow the forest to change in a significant way. However, JGEM should continue the collaboration with Dr. Tiffany Garcia and Oregon State University and study the effects of fire on stream biodiversity. They should collect eDNA, macroinvertebrates, and water quality from 2 streams, one that was in the Beachy Creek fire and one that was not. Both would be at the same elevations in the Cascades. Overall, the data suggests that the best strategy to help burn areas to recover would be minimal intervention, letting nature take the lead. Catchment 7, which had the least human interference, had the most diverse plant and sapling growth. This demonstrates that natural regeneration is the most effective method. However, there are still situations where intervention is necessary, especially in areas where the soil and vegetation have been seriously disrupted, such as Units 2 and 3. For those areas, replanting or soil stabilization methods may be needed to jumpstart the recovery process. But for places like Catchment 7, it's clear that giving nature a little breathing room can lead to faster, stronger, and more sustainable recovery. Moving forward, ongoing monitoring and research will be essential to balance natural recovery with responsible management, helping forests come back healthier after disturbances like fires. We are so lucky in 2020 that the wind changed directions just as the Beachy Creek fire entered Silver Falls. We need to do everything we can to restore burnt forests and to prevent catastrophic fires in the future. Special thanks to the panelists, the Weddles, Ms. Ames, Izzy Mason, Dr. Tiffany Garcia, Dr. Christopher Marshalls, and Dr. Michael Burns from OSU. Any questions?
All right, panelists.
Emily, Marcus, Ashlyn, and Chris, awesome. I love your coordinated green outfits. I know, that's so cute. I
Silver Falls decided to try different methods to see which would be the best strategy. In Cat 2.7, it was not as much in the fire as the rest, so units 1, 2, and 3 are more similar. That's why they wanted to compare them.
Okay, perfect. And then Emily, you said that counting the saplings for future groups should be done differently. What is your suggestion to make sure you don't double count?
I suggest that, so what we did is we had like 2 feet in between everyone, and there was like 2 people on one side and 2 people on the other. I suggest that only one person goes and like thoroughly checks and double checks it both times, because if there's multiple people doing it, I feel like it would be hard to make sure like, oh, someone didn't already count this. Even though it's only 2 feet, it can still make a really big difference.
There might be other ways of marking the trees that have already been counted to make sure that we don't redo it.
You mentioned you counted plants and lichen also. Did you ID those too, or did you just count?
You just counted.
Just counting them? And then were there any other types of saplings that you noticed, or was it just the hemlock and Douglas fir?
It was just that.
Yeah, we mainly just focused on those 2.
You had mentioned that, for the areas that they did log and they raised money to do the recovery work, were they also like, I mean, was it profitable at all? Like, would there be any reason economically to log afterwards?
Like afterwards,
Yeah,
probably not. Like they cleared out quite a bit, like everywhere. It was mainly just kind of like get it out, get it in the open, so the other recovery plans could like go into motion and like profit off like the burn loss.
Good job on this. I noticed as you were talking, you mentioned how Cat 2.7 stood out from the other 3 units, and mentioned higher shade, canopy, moisture in the area. And then I was glad that you kind of circled around to address the fact that it was affected differently from the burn than the other 3 units. Given that that might be a large factor in how it recovered more if it was burned less and maintained more of its canopy, I wonder what conclusions you might draw from the data on the other 3 units. You drew the conclusion that leaving it alone seemed to create the best results. However, it is an outlier from the data source of the other 3 units, given that it didn't burn as much. So, and it struck me that Unit 3 actually, although not as high as Cat 2.7, had different results than the first 2 units. I wonder what conclusions you might draw from those 3 units beyond Cat 2.7. That was a long thing, if I need to reword that more simply. Did the 3 units, Unit 1, Unit 2, Unit 3, can you draw any conclusions from those similarly burned units? Why would you suspect that maybe Unit 3 had higher diversity, higher growth?
Maybe out of those 3 different recovery strategies, the one that happened on Unit 3 was just a little bit better than Unit 1 and Unit 2.
Also, if we did this again, I would, at Silver Falls, if another fire happened to burn here, I would want to like reconduct this experiment and see if it has different results, or it's just that certain area in the park.
Can you recap what the strategies were at Unit 1, 2, and 3? Like, what was
what
the...
happened?
Yeah.
Cat 2.7 was left alone, Unit 1 was thinned, Unit 2 was logged, cleared, and replanted, and Unit 3 was partially logged, cleared, replanted, and partially thinned.
Can I help you out just a little bit? So Unit 1 was thin, but then what happened?
Wasn't there like a windstorm?
Yeah.
And what happened to the trees in the windstorm?
They all got knocked down.
So did they pull out those trees?
Pretty,
No. didn't.
Oh.
They thinned them and then the remaining trees, so unit one is just pretty weird. The other thing, these students never saw units 1, 2, or 3 right after the fires. They saw it after the bulldozer had been in there and cleared everything. So how severe it was, we don't know.
In fact, all of our studies have been post-bulldozer, right?
Yeah.
I'm sorry, I think you might have said it, but the reason that there's so many Douglas fir seedlings, but did you say that's because they planted Douglas fir, or that's just what's like regrowing naturally?
Some are replanted, but like in certain areas, western hemlock are growing more because of like the way they grow, because they need more shade to grow. And then Douglas firs are thriving more in other spots because they have more summer.
Yeah, so it really just depends on the area.
Yeah. Thanks.
Got about 4 or 5 more minutes. Are there more questions? Do any past researchers have any questions? Alex?
I was curious if you think that some of the succession strategies used in the other units, other than CAT 2.7, could show better results if given more time.
Can you state it louder, please?
Do you think the other locations than CAT 2.7 could yield better results if they were given more time?
I think so, maybe, because if we do the 2-year process, it may change, like, just by us leaving alone, and I would really like to see if it would in fact change and become better than CAT 2.7.
I think the discrepancy between CAT 2.7 and the other units has decreased over time. Am I remembering that correctly, Mr. Weddle?
Yeah, there were a lot of plant cover in some parts of Unit 1 and 2. Places where there were still severe bulldozer tread divots and things, nothing was growing, but there were fireweed and all sorts of things that you might expect after a fire that had grown. So, yeah, I think you're right, there will be more and more, and I'm very anxious to see it in 2 years and 20 years from now.
Did you all find like a difference of wildlife in each location at all?
I think we really only saw birds flying around. We didn't see any.
The occasional like that was really
Yeah,
bad.
chickens.
What did you hope to use to find wildlife evidence?
eDNA.
So in the past, in last year's group, they used camera traps, and do you remember, did you look at that and see what they found last year with the camera traps?
Didn't they find it?
They found coyotes, right? They found coyotes and like deer.
Deer and bear. So why did you switch from camera traps to eDNA?
One of the past panelists suggested it, and because we might get more data from it.
So you didn't, then you said because you just had limited time to do that collection, you got human, Homo sapien was the only thing you got when Tiffany Garcia came, and she taught her students out here, and we got things, squirrels and stuff. You just got, are you sure it was human? Is there anything else in the forest that closely related to human that it might have been? Thank you.
Thanks, Ashley.
That's yours.
Extra credit.
Yes, I think it was big. So you talked about the sample, Frank, I don't quite understand what that machine reads. So you take your little filter and it's got the fragments of DNA. How does that work? What does the machine look for?
It looks for similarities between the fragments of DNA that we got and all the DNA that it has in its machine.
So looking for any matches?
Yeah.
Okay.
Alright, I think that is the end of our time for fire. A round of applause for them.